Today we're going to be looking at some different angles, and we've talked about drawing angles previously and naming them. So if we were to draw a line EK, which would be here, and then we drew angle EMC, which means we have to draw a ray M to C to complete that, and draw angle CMK. Well, CMK would be here. We want to draw the angles interiors in two different colors. So our construction looks like so. This is an example of a linear pair of angles. How would you describe a linear pair of angles? Some of you may say, well, they are angles that are next to each other, which is true. So they share a side and a vertex, right? And some of you may also say, well, if you started at one point here and you went all the way over, right, it's forming a line. So from here to here, how many degrees would that be? Well, you know from measuring angles before, that would be 180 degrees. So we could say a linear pair of angles share a side and together form a line. Their sum of their angles is 180 degrees. All right, doing another construction. Again, if we drew our line EK, this time also draw a line CI, we're going to have some angles form. We want to mark angle EMC and IMK in different colors. So by drawing the two lines EK and CI and shading in the two different angles EMC and IMK, these angles represent vertical angles. They share a vertex here at M, but they are not adjacent to each other. They don't share a side, right? They're not next to each other. We've got them kind of across from each other. So how would you describe vertical angles? They're formed by two intersecting lines or segments. They share a vertex and sides being opposite rays from each other, right? So these are pointing in this direction and these are pointing in the opposite direction. Well, when these two lines intersect, how many angles do we have? Not just these two angles individually, but we also have these two angles individually as well. So we actually have two pairs of vertical angles that are being formed. So IME would be a vertical angle to CMK. Looking at the angles and how they're formed, do you remember anything about their measurements? Well, vertical angles, based on how they're formed with the intersecting lines, they have the same measurement. They would be congruent to each other. So the measure of EMC, if we took our protractor and measured, it would be the same as IMK. So you have to remember that vertical angles are congruent. Doing another construction, if we made angle GMI and shaded it, and IMJ and shaded that, these are adjacent angles because they share a common side, ray MI, a common vertex, and they're not overlapping. So the angles are next to each other. These angles do not have a relationship with angle measurement necessarily, just that they have a common side and a vertex. If we draw angle BMJ and shade that, and draw angle HMF and shade that, these would be non-adjacent angles because although they have a common vertex, they are not sharing a side. And as of right now, if we measured the angles, we could see that they do not have a common measurement, right? They just have a common vertex. So again, here's an example of what non-adjacent angles could look like. If we drew angle EMC and angle CMK and shaded those, we can say that they are supplementary angles because their sum is 180 degrees. So if we measured here for EMC, right, and CMK, together we know it's 180 degrees. Could these be classified by any other names? Well, in this case, sure, we could classify it as something that we saw previously. We could say that it's a linear pair, or they're adjacent angles. Now, based on the definition, we know supplementary angles have a sum of 180 degrees. So when two angles add together equals 180 degrees. Does that mean that supplementary angles always have to be adjacent to each other? The answer is no. By definition, it's just the sum that has to be 180 degrees. They don't have to be adjacent to each other. It's just when you add the two measurements, it has this for the total. So of course, non-adjacent angles could also be supplementary to each other. If we constructed angle EMC and CMB, what would that look like? These two angles would be called complementary angles because their sum is 90 degrees. If we measured EMC and CMB, their total would be 90. Could these angles be classified by other names? Yes, using vocabulary that we had before, they could also be known as adjacent angles because they have the common vertex and the common side. Well, do all complementary angles have to be adjacent to each other? By definition, it says complementary angles exist because they have a sum of 90 degrees. So as long as two angles' sum is 90 degrees, they would be complementary. Therefore, they do not have to be adjacent to each other to meet that definition. So to recap, some of the angles that we've talked about up to this point have been the following. We know if it's just a ray, that's a 0-degree angle because there's nothing to measure to an opposite ray for a measurement. So here it's 0. We've talked about acute angles having a measurement greater than 0 but less than 90 degrees. Right angles having a measurement of 90 degrees exactly. Obtuse angles having a measurement more than 90 but less than 180. A straight angle having a measurement of 180 degrees. We've talked about adjacent angles that share that vertex and a common side. We've also talked about vertical angles, right? Because those rays are going in opposite directions, but they have the same measurement. And in previous lessons, perhaps we talked about the central angle, right? Where the vertex is at the center of the circle, extending out to the sides. And here's your angle right here in between the two rays. Other things that we know. Vertical angles are congruent to each other, and when two lines intersect, there are two pairs of vertical angles being formed, right? This is a pair of vertical angles that would be congruent. This is another pair that would be congruent, right? Vertical congruent. These also would be congruent. Here we have a pair of angles that are not vertical to each other. So can you see the difference between the ones that are vertical versus ones that are not? We talked about before how adjacent angles are angles that share a vertex and a common side. So here's 3 examples of adjacent angles. You could see the common vertex and the common sides, and how these are not adjacent angles because they don't have a common vertex or a common side. Here they have the common vertex but not a common side. And here angle 1 and ABC. See how 1 is part of it? Again, common vertex, but no fully common side for the measurements. We talked about linear pairs of angles, right? 2 angles that are adjacent to each other have a common side, common vertex, and the measurement total, right, is 180 degrees. So again, these are adjacent angles, but the total is not 180, therefore they're not a linear pair. We talked about complementary angles having a sum of 90 degrees. They could be adjacent. They don't have to, but the sum has to be 90. That's why these would not be considered complementary angles. Supplementary angles have a sum of 180 degrees, right? So supplementary, they could be adjacent. They don't have to be, but a total of 180, total of 180. Again, you have to know the angle measurements to get that total of 180, and it's 2 angles, not 3, right? And if we measured these, again, together, we would not have 180 degrees. So let's put these definitions into practice. We've seen a variety of each type, and let's see if we can do some solving. So here we want to fill in all the angle measurements. Well, we have 2 lines that are intersecting with each other, and 1 angle measurement is given. We should be able to find the other 3 missing angle measurements. Well, what do we know that can help us? Well, based on what we have here, we can see we have some vertical angle pairs. So if this measurement here is 125 degrees, we know its vertical pair would also be 125 degrees. That would go here. Now, we also have another pair of vertical angles here, and their measurement should be the same. Well, is there a way we could find out their measurement? Well, if we know that this angle here is 125, not only does this belong as a vertical pair, but this angle and this angle make up a supplementary angle pair, right? A linear pair to each other. So the linear would be 180 degrees. If you used up 125, when you take that away from 180, that would give you this angle measurement here. Therefore, you can get its vertical pair. So going through the mathematics, remember 180 minus 125 would be 55. So that would be the measurement for this angle and its vertical pair. Again, we talked about the vertical pair here being 125 degrees. So the two angles that we use were vertical angles being congruent to answer the questions. Also, linear pairs have a sum of 180 degrees. Well, if this is our picture given to us, could we fill in the measurement of the angle that's missing and tell us about how we found it? Well, by looking at our picture, what do we know? We know that angle ABD is 90 degrees. We can see that with our mark here, right? The universal symbol for a right angle, 90 degrees. We know angle CBD is 12 degrees. Well, if our total should be 90, we've used up 12. That means ABC would be the difference. 90 minus 12 is 78 degrees. Again, we use complementary angles having a sum of 90 to find that result. So if this is our diagram, could we fill in all the missing angle measurements? So the first thing is, what do we know about it? The first thing we should see is this mark here. Again, the universal sign for a right angle being 90 degrees. Okay, so this angle is 90 degrees. This angle is 30 degrees. If I started here and measured all the way to here with my protractor, we know that should be a total of 180 degrees. Well, if 90 is used up here, that means these two angles would have to have a total of 9 degrees. These two angles would be complementary to each other. So 90 minus 30 would be 60 degrees. So what other types of relationships, do we notice? Well, if this angle is 60 degrees, here's a line, here's a line. When two lines intersect, they form vertical pairs of angles. So if this angle is 60 degrees, it's a vertical pair to it, should be 60 degrees. So we know this angle here. Now, that's not the only place where two lines intersect. We have this line here and this line here. So that means we have another pair of vertical angles that we could use. Here's a measurement of 30 degrees. Its pair should be the same, which would be here. So again, using vertical angles being congruent, we have that angle measurement. Now we have one angle measurement left to find, and that's this part here. So there's a couple ways to do that. We know that if this is 90 degrees, right, these two angles are complementary to each other. And from here to here, right, that would be a straight angle, 180 degrees. So if this is 90, these two should have a total of 90 degrees as well. If you've already used up 25, the difference would be this angle measurement here. So 90 minus 25 is 65. That's our last missing angle. Now, instead of using this pair of complementary angles to help find this pair, you could have also used this pair of complementary angles, right, to help you figure out that had to be 90 as well, and then finding your total. All right, so let's try one more. Here's our given picture. Can we find all the missing angle measurements? Okay, so we're going to have to find some angle relationships. So here, your eye should be drawn to this right angle symbol, right, 90 degrees. This section here is 80 degrees, which means this should be the difference. 90 minus 80 is 10 degrees. So using our knowledge about complementary angles. We also see that we have a pair of vertical angles with these two pairs of intersecting lines. So if this is 12 degrees, this angle here would be 12 degrees. We have another pair of intersecting lines here and here, making a vertical pair of angles. So if this is 10 degrees, its pair would be 10 degrees. That means this angle here. Now we have two angle measurements left. I'm going to focus on this angle measurement here, right? So what do we know? Here's a line, right? So this angle measurement here is 22 degrees. This angle plus this angle should give me a total of 180 degrees because this angle and this angle would make a linear pair. So if I have 22 degrees here, 180 minus 22 would give me the angle measurement that I need, which would be 158 degrees. Notice we could have done the same thing here, right? Because it's the same measurements. This angle and this angle would be that they're supplementary because it's a linear pair, and we can find that difference as well. Now, is there a way that we could find this angle measurement? This angle measurement, we could do a couple ways. We could use the same idea that we did in this last one, knowing from here to here is 180 degrees, right? Straight angle. So we could subtract what we know from our givens, this one, and this one, and that would give us the angle measurement here. So again, this is our 180, right? Subtract what you know from here, here, and here from that total. That leaves you with 78 degrees. Now, is that the only way you could have done that? No. We talked about how these two angles were complementary, right? From here to here as well. That's another straight angle, so that total should be 180. 180 minus 90 is 90. So these two here are complementary angles with a total of 90. And so again, 90 minus 12 is 78 degrees as well. So now it's going to be your turn to practice more with your angle relationships and finding some missing measurements based on those givens.